Hello everyone. We go with CMS Manhattan series, and I would like to introduce our optimized models which you can use for your local environment. For example, if you cannot use internet in your bank network, but you have options to download model in ONNX format, for example, like Llama, or you can convert any PyTorch model to ONNX format. ONNX format designed to deliver model from every framework. Every framework have options to convert any model, any framework made based on this model to ONNX format. But you can find any model already converted to the ONNX format on Hugging Faces, or you can use just any Python script which you can get from AI, from Grok, or maybe from ChatGPT or Gemini. But you can download, for example, already converted model ONNX formats. For example, from Hugging Faces, you can see many model in ONNX format. For example, there are many models such as a model Q4, model int8. It means weights of this model converted to different type. All vectors in this model will keep value in int4 or int8 format. This way we'll not use big float formats which contains a lot of memory, and of course we'll spend more CPU with additional operations for float type. And you can do quantization. That also any AI can make your script to quantize your model. It's very simple, but we not discuss about quantization. We discuss about optimization model running in ONNX Runtime. There is a framework designed to run do inference for models with ONNX Runtime. ONNX Runtime. ONNX Runtime. Yeah. You can find project on the internet, ONNX Runtime. This is a library which supported by many languages and allow run ONNX models, and ONNX Runtime that give you very good performance for your models. What I do, I use Java with ONNX Runtime. Yeah, it looks like not a very simple way to use ONNX Runtime directly. It's it's a little complex. Yeah, you have to handle with tensors. You have to use your tokenizer to decode your text to digit representation, and send this digit representation arrays to your tensor. There are many tensor input tensors and output tensors. For example, we have a embedding layer in Llama transformer. Here we send our input vectors or embeddings. Yeah, and in this tensor with input IDs. And next we have another tensor, which position tensor, which also sends another bunch of vectors to there. And also we have one more tensor, input tensor for mask. We also send. You have to populate this tensor for extension mask tensor, and we submit that, and we have one more. We have a response in our last tensor, output tensor, with logits. Logits, it's already predicted. Have predicted result. Vectors with predicted results. We actually we got vectors, logits, output vectors, and convert them in our text using decoder using decoder from our tokenizer. Yeah, you can see over here. It's not very simple code, yeah, but in order to reach much good performance, you have to do this. You have to go through model architecture, understand what input tensor you have, what output tensor you have, and feed them and get results, and use tokenizer to encode and decode value for that. Yeah. Usually I did that, and just show. I would like to show ready solution, which I did for everyone. Yeah, this is actually a ready solution, but I use my GRAC model for this. But you can actually use also Llama model, which I have on Docker. If you go in CMS Manhattan Docker repo, you can find a lot of models. Yeah, you can see Llama models and T5 models. I have a lot of Llama models, instruct models, because if you would like to train Llama for example, question and answer, best way to use instruct model, yeah, for that in your rack system. Yeah, but you can see many quantized models in ONNX format, which corresponds our community Llama, ONNX Llama, which are already made for Hyper. Yeah, like here. But I can show example. How it work in my web service for JRock. You can download the same thing for Llama. I have a lot of service implemented. For example, we can say something, hello, and submit our request. Okay, and you see model responded. Hello, I am AI assistant. How can I help you? Actually, this is running in my Docker container. You can see here tracing Docker container. You can see my web service Spring Boot over here with Swagger, ONNX Runtime, running in my Docker container. What is good, you can use this web service along together with Eureka Discovery Service Discovery and IP Gateway, and you can do load balancing, uh, like you do microservice load balancing for Spring Boot. Yeah, this microservice architecture which I implemented. Yeah, that you can use in your intranets if you cannot use internet by security reason. And that's it. In next series, I will explain how we use that uh, more easy way without use ONNX Runtime directly. Uh, there is a library called GDL. In GDL, have a model zoo. Model zoo is number of models which you can load on an X format. You already some code already implemented for inference the models. You don't have to do like I do here. You just make more easier life for you, to easier way to develop something. But number of models which you can use restricted. If you would like to do something custom and work with other models, you have to use this way, which I do, to use ONNX Runtime framework directly. Thank you very much for listening. Follow my next video. I will show you how we could use Model Zoo to work with ONNX Runtime and implement your model with web service writer very easy way.